Hello everyone, welcome back to my channel. Hope you all are doing good. Now we are going to talk about the classification or the types of machine learning, and hope you have already gone through the previous introduction to machine learning, and I hope it makes sense to all of you. And now we will start with the topic for today. Let us start with the topic. So today we are going to talk about types or classification of machine learning. So we understood the introduction part, and we understood what is the machine learning life cycle and how it works, right? Overall, how it works. Now we will understand, to make it work, what are the components or what are the things which are contributing a lot for that. Okay. So basically, ML or the machine learning is divided into four main categories. However, we are most of the time we are talking about supervised, unsupervised, and reinforced. Here, one more category is also there, which people are hiding a lot, and that is nothing but semi-supervised learning. So we have, in short, supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning, and each of them are characterized, okay, to predict the conditions or to identify the patterns and to produce the outcomes. So basically, it will predict the different conditions. Whatever the data sets which we have, it will take that and it will predict what are the conditions available and it will give you the output. So first we'll understand what is supervised learning. I will give you simple examples which will make sense, and it will be easier for you to catch it. Okay. So supervised learning is a method, or it's a type of algorithms which used labeled data and unlabeled data. I will explain you in short. So it will take the labeled data to predict what it will predict. It will predict the outcomes, or it will predict the target variable, right, guided by some inputs and outputs pair. And in this case, you knew, or we all knew about the input, like what is the input and what is the output we are giving. Nothing is unknown here. Okay. In supervised learning, we are taking labeled data. Just that's it. You just need to remember that you need to take the labeled data to predict the outcomes. And here, input and output we all knew from starting. I will give you examples in short. And these the algorithms which are using here, right? It will, like, what it is taking, it is learning, okay, the input features, okay, to known outputs and enabling them to predict outcomes for unseen data by recognizing the patterns. Here, I have shown one example. So you can see here, right? We have different categories of cats and dogs. We have different categories. In supervised learning, it has the capability to consider or to segregate. Like, we know, okay, what is the input here? We have cats and dogs, two inputs are there, and we want the output, which one is cat and which one is dog, right? So here, I have given all the inputs, cats and dogs and everything. I have given the input. So cats have features like this eye color and the type of hair, the color of them. Similarly, the dogs have, they have they have the color again. They have the eye type, like the type of breed, and all those characteristics will be there when we're talking about. And we will give input all, like we will provide all kind of these inputs to machine, and it will predict which one, based on the characteristics or based on the type of characteristics or the type of features, it will predict which one is cat and which one is dog. So what is our target here? We want to know the type of animal, and that is cat and dog. It is going to, that is our end, or that is our output. So same thing we have here in this image which we are explaining, right? Similarly, I will give you one more example. See, we have, let me just get my pen. If you'll take, okay, if you'll consider, let me take a table here. First, I'll explain what is labeled and unlabeled data. And this is very important thing, guys. Like most of the people are failing to explain it in a correct manner whenever they are going to interviews. Okay. So, in a data set, okay, I have these columns present, and these columns have, something like the names are like A, B, C, D, and E. So my question here, are these the labels? Basically, what is label? Label means here we are talking about features. Features, again, what are the features? Whenever we are getting the data set, the data set is having multiple rows and columns present. And those columns, each columns of the data set is called as features in case of machine learning. Okay. So here, when I'm talking about features, are these features making sense at all? These are not making sense. These are not meaningful, right, for us? A, B, C, D, are these meaningful? These are not meaningful. So, when we are talking about meaningful features, those are called as labeled data or labeled features. When the features or the characteristics have some meanings. So, if you replace, consider that you have a student table and you want to, or consider that you are, going to a medical or the hospital, and they are taking the features of you like BMI, the blood pressure, the height, the weight, and all these things. So if you replace those values here like height, okay, weight, BMI, okay, BMI, then cholesterol level, then blood type, blood group. So when we are, replacing these values here, these are called as label data because each and every feature have some meaning, and those are pointing out to what? To a person's data, to a person's medical data or medical history. This is what your supervised learning. So when we're talking about label data, we know, okay, what is the input. So here we know, okay, we are providing height, weight, BMI, body mass index, then, blood group, then we are talking about, cholesterol level, because these are the basic features which are considering that when we are talking about the medical history. The patient has any diabetes history or not. So everything we are taking the, patient's history. So when we're talking about, when we're giving those inputs, what is the output we are predicting here? We are predicting whether the person is healthy or not. The person or the human is healthy or not. And that is where we are telling our machine, these are my inputs and this is my output, predict. So next time when some new patient data we are going to give input to machine, it is going to predict the output whether that particular person is healthy or not. So that is what your supervised learning. And we will understand each and every algorithms in our upcoming videos, but conceptual wise you need to understand right now, and I'm explaining on the set. So I hope this supervised learning makes sense. Now we will go ahead on what are the factors or how supervised learning works. We will understand each and every characteristics. We will break it down. So first we understood, okay, label data. When we are giving input, okay, the process or the label data or the supervised learning process begins with a data set where each and every input data point has corresponding output, and which we are talking about the target variable. And here two more concepts will come: dependent variable, independent variable. So independent variable and dependent variable is nothing but the cause and effect phenomena. Cause and effect phenomena, what is that? When we are talking about dependent variable, that dependent variable is depending on these independent variables, where how those variables are modifying their characteristics, and based on that, that dependent variable will act or will get the output. That is what a cause and effect phenomenon, right? So here the same thing applies, label data, right? Then training. When once we get the label data, we are segregating dependent and independent variable, or we know the target variable, we will start with the training the data. So in supervised learning, what it does, it learns the mapping between the input features and output features from the labeled training data. Again, like I will explain you, we are segregating training data, validation data, test data. Then we are proceeding with, providing the test data, training data. Then it is going to predict you the test or the result or the output. So the same thing in the third point we have here, prediction, right? Once that model is trained with the training data, then it will give a new and unlabeled data. Unlabeled data here means new data, right? New same patterned data, because it is always understanding the pattern. It is always recognizing the pattern, how it is going to give you the output, and it will use the mapping and predict method, and it is going to give you the output. So these are the three important factors. Labeled data first, then second, it is going to get trained. The algorithm is going to train the model, then it is going to predict with the new data, right? And like here, basically in supervised, we have two different fundamentals which we have to understand, and we will understand more broader way in upcoming videos. But you have to understand that we have two things. One is regression and another is classification. So the supervised learning is divided into two things. One is regression and another is classification. So regression is always, it is based on the continuous data, and I have already explained you continuous, discrete and everything. Please go through the previous videos if you have missed it. Okay. So regression is when we are predicting on continuous numerical values, for example, house prediction price, right? Then when we are talking about classification, again, it is on a discrete category. Discrete category means true, false, okay, spam or not spam, right? Correct, incorrect. So these kind of categories are coming under classification. And classification, again, it is not based on only two output. Multiple classifications are also there in the picture, and we will understand in our upcoming videos. Okay. So till this we understood how supervised learning works. Now we will understand how unsupervised learning works. Unsupervised learning, again, we understood that supervised learning is based on labeled data. Unsupervised learning is based on unlabeled data, right? Opposite. And what is unlabeled data, guys? I'll give you one example here. So when COVID came, right, when the COVID phase was there, during that time, during that time, what happened? These scientists or the people, because it's a new thing, right? Nobody knew it's going to be a pandemic. Nobody knew about that. What they did, they have taken different clusters or different groups, and they have given group 1, group 2, group 3, group 4, like that. Because the patients who are coming and who are complaining about their symptoms, the symptoms are something similar to COVID. Some symptoms are not similar to COVID. So they are grouping into it. They are grouping. And when we are talking about grouping, that is nothing but your unlabeled. Because we are not labeling, we are just grouping. And that group, we are giving some name, group 1, group A, group B, group C, group D, or type 1, type 2, type 3, type 4, like that. And we are understanding the patterns, hidden patterns, the structures, the relationships among that group for each and every items, and we are giving the consequences or the outputs, right? And whenever some new things comes into picture, people are going ahead with this kind of learning, right? And it completely relies, okay, on techniques like clustering, like I said, clustering, then dimensionality reduction, my bad, to understand the segment or the pattern and simplify the complex data sets. And it will allow the model to identify the insights and it will make the prediction. So in this example, particular example, you will see that I have different colors. You can see different patterns of colors are there. One is a green circle, then one blue circle, then one yellow circle. So if you see that it's there is a group, right? And when unsupervised learning will happen, it will make it into group, okay, different groups. So it will create. There are so many algorithms are there just to understand these patterns. So it will understand the pattern. Okay, I have one yellow patterned group, one green patterned group, and one blue patterned group, and it will segregate and it will give you the output. So basically, it is grouping. It is grouping and it is understanding the pattern. That is nothing but your unsupervised learning. And in the next slide, we will understand how these learning works. So these are the characteristics, like the way we understood supervised characteristics, we will understand unsupervised characteristics. So here again, like I mentioned, it is based on the unlabeled data. There is no meaning. All features, there is the features which you are depicting here, there is no meaning here. And the algorithm, okay, is provided with the data set here, which does not have any, output label or category, anything predefined. Nothing is predefined here, okay. Then we will understand how it is discovering the pattern, right? When the model wants, it will get the input as a data set input. The model analyze the data, okay, and identify the similarities, the commonalities, and the differences between the data points. Like I said, similarities, if in a group, in the previous example, we have yellow, so yellow circles. So it will understand, okay, the circles are yellow and that needs to be in one side. The blue circles needs to be in another side and the green needs to be another side. So commonality coming into picture, right? And similarities coming into picture. Then structure identification. Most of the times it is going to understand from the features, and by creating clusters, it will understand the structure. Like I mentioned about the COVID case, right? The COVID, there are so many variants coming to, during that time, so many variants are there. And how they are doing based on the patient symptoms, they are segregating or they are grouping the patient. And they are understanding, okay, this variant comes into picture for this particular group of patient. Another variant is coming into another set of, people or another set of patients. Like that, they are understanding or the identifying the structures. Then the refinement. What is refinement, guys? When the algorithm is refining, based on the meaningful groups and the representation of data, that is called the refinement process. So once it is identifying the structure, what it is going to do, it is going to give you the output, right? Then last page. So what it is going to do, the algorithm will completely stay unbiased and it will understand the pattern and it will tell, okay, this comes into this group, so that is final. And that is nothing but a output, refinement process and output. Okay. Then we will go ahead and understand what is semi-supervised learning. Okay. So semi-supervised learning, again, the name says, right, it is a combination of labeled data and unlabeled data. And the labeled data which you are taking, those are small amount of labeled data, and unlabeled data which you are taking, those are large amount of unlabeled data. Okay, this is for your understanding. You don't have to worry much about it. So like supervised learning, right, it understands or it aims to learn, because machines are going to learn the patterns. Every algorithm, they are learning the patterns and they are giving the output or the prediction. Okay, so it learns a function, okay, that accurately predict the output variable based on the input variable. Same case, right? Then it uses those unlabeled input which are there, like it is a combination of two things, right? Supervised and unsupervised. In supervised learning, it will take those labeled data and it is going to give you the output, predict the output variable from that. Then whatever the unlabeled data are present, okay, it is going to assist that learning process of whatever the supervised learning process is there. It is going to assist that, and it is going to conclude the generalization, the model generalization. Okay. So that is how your input and output structure comes into picture. So first it will take the the label data and it is going to find out the output variable from that pattern. Then the same thing continues with the unlabeled data, whatever the unlabeled input is there, and it is going to continue the learning process and it is going to give you the output. You don't have to understand much, but just understand the topic. It might come into your interview. Then we will understand the reinforcement learning. Reinforcement learning is a type of learning where the algorithms learn, okay, by performing actions. Whatever actions it is going to perform, it will get the reward. If it is not going to perform well, they are going to be penalized. So that is nothing but a reinforcement learning. And one of the example which we have and which are using daily in our daily life, that is nothing but GPT, Chat GPT. Chat GPT is an example of reinforcement learning, and reinforcement learning is a complex type of learning, very complex type of learning. Here we are talking with the machine directly. We are interacting with the machine directly. That is nothing but a reinforcement learning. And here the process is something like, here the program finds, okay, the correct solution. If the program finds the correct solution, it is getting rewarded by the algorithm. If it is incorrect, it is going to be penalized for the incorrect prediction. So the next time whenever machine is going to react, it will think twice. No, I am getting penalized. I should be careful this time, right? So it's a kind of interaction with the machine, right? So yeah, that is nothing but the gist or the understanding of reinforcement learning. Now we will understand this picture, how this reinforcement learning works. So reinforcement learning involves agent. Like I mentioned, right? We have agentic AI, generative AI. Those are using reinforcement learning to train their model. So agentic AI, again, the way agentic AI is there, that uses agents to predict or to help in our automation part, right? So similarly, here the agent interacting with the environment, right? You can see in this image, we have agent, right? We have agent, and that agent is interacting with the environment, and it, like, during the process of learning, they are getting rewards, okay, and based on the rewards, they are choosing the best action and improve the performance. So in this example, we have different kind of shapes present, like we have star shape, square shape, then circles. So how how it is going to work? During this process, it is going to segregate the different shapes, right? And the same thing, every time whenever the agent is interacting with the algorithm, it is getting rewarded for getting correct output or identifying the correct shapes. And that is how your reinforcement learning works. Some real-time examples of reinforcement learning, and that is nothing but one of the example is nothing but your YouTube recommendation, right? Whenever even Netflix recommendation, YouTube recommendation, that is, these all are your reinforcement learning, right? Because they are using these patterns or these to understand this reward and penalty program in each and every page of their learning process, right? Whenever a user searches for any particular song or any particular topic, the program shows the list of available songs, and that is how your recommendation works, right? And whenever a user selects that particular song or topic, what is happening in the back end, on the behind the scene, the system or the algorithm trains itself, or the training or the learning is happening in such a way that the system understands, okay, this is the pattern and this is the type of song or the type of topic these people, like this particular learning process I have to handle. And based on that, every time whenever you are searching, or if you're not searching also, it is going to recommend, okay, these are your searches and these are your likes. Okay, that is how your reinforcement learning works even in real life. Okay, here there are different kind of examples. Okay, you can see one of the example where the games where we are players are playing with bots, right? Take any example of games where the bots are when you're talking about computer is playing, right? So that is nothing but a reinforcement learning. Self-driving car is a reinforcement learning. Autocorrect tools, that is your reinforcement learning. Recommendation engines, ChatGPT, right? Everything is your reinforcement learning. Then we will understand these parts we understood in our previous videos. Again, we will understand what are the libraries which we are using in our machine learning, right? So, one is your NumPy. Okay, NumPy is a powerful library for computing numerical or the numerical side of the understanding, right? Then we have Matplotlib C1 for understanding visualization and graphical plotting. Then we have Pandas, right? Pandas is for data structures. It is going to give you the structured way of understanding or handling data, right? Then we have SciPy. SciPy involves mathematical and mathematical equations, and it is helping to process the algorithm. Scikit-learn. Scikit-learn is very important algorithm. It has all set of algorithms which are getting used throughout our machine learning journey, and it is helping to develop the different kind of models, right? So this is what we understood our different type of machine learnings, right? And let me summarize all those things again. We have supervised, unsupervised, semi-supervised, and reinforcement learning, right? Again, supervised, we have we knew input and output all together at the same time, and based on the input data, the output is getting predicted, and all are interrelated to each other whenever we're talking about supervised learning. Unsupervised learning, it is based on the clustering, grouping, okay, and understanding the hidden patterns, and it is going to give you the output based on the similarities and understanding of the identity of all those groups, right? Then we have semi-supervised, where we are using small amount of input data and or labeled data and large amount of unlabeled data, and first it is going to understand the pattern or the output pattern from the labeled data, then the same thing it is going to be helpful for understanding the pattern in the unlabeled data, right? Then reinforcement learning. We have reward and penalty system. Take one example. I'll give you one more example. That's what I was talking about previously. We have, consider that case of a small baby or small child, okay, of 2 or 3 years child. Uh, none of the child are born with so much of knowledge, okay, this like to identify the objects or to identify the people, right? Who are their mom, who are their dad, like that. However, you as a parent or as a person, if you'll give, take one example, if you'll give a mango, okay, or if you try to talk in front of that baby maybe 10 times, okay, you want to teach your baby one particular word, maybe saying hello. So the first time they won't respond, the second time they won't respond, the third time if you will say like hello and they will respond, if you'll say wow, you're doing good job, or you'll just clap in front of them, they are thinking that as a reward. You must have observed it. They are thinking that as a reward, and they are improvising themselves next time. So whenever some incident or something happened and whenever you are saying hello, they will repeat along with you hello, and again you will give the good response to the baby or to the kid that you are doing good by clapping. Then they are understanding that okay, I am going good or I am doing great, right? And if at the same time, if they're doing wrong, you are saying no, you're not, this is not the correct way. If you say no, they will understand that and they will correct themselves. So the same concept is applicable in case of reinforcement learning. Here, agents are coming into picture. Here, the environment is coming into picture, and altogether, the algos or the algorithms are there who are continuously working on making them understand, right, by providing rewards and penalties. So that is nothing but your reinforcement learning, and we understood all these things nicely, and we will understand further topics in our upcoming videos. Okay, so till that time, see you, bye. Well, that is all for now. We will cover further topics in our upcoming videos. Till that time, see you, bye, take care. Please start subscribing if you have not done that. Like, share your comments, share your valuable feedback, share this channel link to all your friends and near ones. Till that time, see you, bye, take care.